So sets and Venn diagrams, right? So a Venn diagram is a number of overlapping circles. Today we're going to worry about a two-circle Venn diagram. And so inside the box, right, is the universal set, whatever we're talking about. It could have been the set of digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. And that splits this into 4 regions then, right? We have the region that overlaps, which are elements of set A and set B. So we call that A and B. So it belongs to both set A and set B. We have this area, which is the elements that are only in set A, okay, not in A and B. So we call that A only, or only A. And then we've got this, which is only B, right? So again, excluding the region of intersection. And then outside of those 3 regions are elements of U that are not part of set A or set B, so we'll call that neither A nor B. Okay, and we did an example like that the other day, right, where we had stuff that was outside of the 2 circles, it was in the intersection, I think we might have even done 3 circles. So what we need to do is make sure that we have that language down. This is A and B, right? It's in both set A and B, only A, only B, and neither A nor B. So 40 students were surveyed as to whether they like the show Riverdale or the show Never Have I Ever. 25 students said they liked Riverdale, 10 students said they liked Never Have I Ever, and 8 students said they liked neither. So let's label the 2 circles, right? We're going to have the Riverdale circle, we'll have the Never Have I Ever circle, we have some overlap, we have the universal set. So we want to put 4 numbers in here. All right, so there's 4 different numbers. Riverdale only, Never Have I Ever only. So can I put any one of those numbers down right now? So 25 in R, but how does it split out? How many were only Riverdale and how many like both? 25 where? There's 2 regions inside R. We don't know what the breakdown is, right? We know that inside R there are a total of 25, but we don't know how to split it. Okay, what about the 10? Well, we know inside the N circle there are 10, but we don't know how to split it. What about the 8? Can we put the 8 somewhere? Where does the 8 go? Outside of the circles. Okay, so we have one piece of information that we can label, right? Put 8 outside of the circles. Now, that leaves us 35 to deal with, right? But I can't put 35 and 8 together. That would give me 43. We've only got 40 in total. Okay, so of the 40 students, we have dealt with 8 of them, which leaves us 32 students left to deal with. Okay? So of the 40 students, we have placed 8. We know that the other 3 numbers we put down are going to have to add up to 32. But these add up to 35, so what does that mean? Is 3 of them will belong to both. Right? So if we take the 35 students that we have left to put in there, but we say there's only 32 spots for them, then there are 3 that belong to both, right? That like both Riverdale and Never Have I Ever. Now, inside the Riverdale circle, we need 25. We've got 3, so how many go here? 22, right? Inside Riverdale, we need 25. We've already got 3. Inside Never Have I Ever, we've got 3. So how many go here? Okay, let's add it all up. We've got 7, 10, 32, 40. So we've accounted for all 40 students, right? We haven't done any double counting. That's what would have happened if we tried to place the 25. We didn't know how the 25 split up. We didn't know how the 10 split up. We did know that 8 went outside here. So how many like both TV shows? 3. Okay, so in the overlap is both Riverdale and Never Have I Ever. How many liked only Riverdale? So only Riverdale, 22. Only Never Have I Ever. How many liked only Never Have I Ever? 7. Okay, so we've got Riverdale only, right? It's a section where there's no overlap. It's just only Riverdale, 22. Never Have I Ever only, outside of the intersection again. 3 in the intersection. Draw and label a Venn diagram to show the data. This is actually where you start. Start with the Venn diagram, then answer the question. Okay? So that's the deal. When you've got a 2 Venn diagram thing, start with the diagram, fill it in, answer the questions from there. Okay? You can't answer these questions first, right? We can't answer them first unless we know. Billy drew the following Venn diagram incorrectly. There are 30 items in the universal set and 5 that are in neither A nor B. Okay, so is there anything on there that is correct? That we know the number is correct? The 5. Right? But the problem is, how many does this add up to? Adds up to 35, but there's only 30 items. Okay? So if there's 5 items here, and there's 30 total, then how many do we have left to place? Okay, so 25 left to place. So assuming there are 20 in the A circle and 10 in the B circle, but I got 25, then how many must be in both? There's going to be 5 in both, right? Which takes this A only down to 15, giving me 20 there, giving me 10 inside here. So we've got 15, 20, 25, 30. Okay, so his mistake was the one we almost made before. Oh, there's 20 and 25 in Riverdale. I should put 25 in. So no, we don't know how it splits up. Okay, so we have to look at, there's 30 items in total. We've taken care of 5 of them. That leaves us 25 items left to place. Okay, now we're going to assume Billy figured out that there were 20 items in A, but he didn't know the distribution of them. So, N, A, and B. How many are in A and B? 5. How many are in A only? How many are in B only? Okay, so little n meaning the number of. So the intersection of sets. So and A and B, A intersect. That little upside down U means intersect or intersection. Okay, so it's on your formula sheet. That one's blank. It's on your formula sheet. And it's got that upside down U, it's not quite a U, but which says intersection. So when you see that intersection, the upside down U or the word intersection, so just the intersection is where they intersect, right? Where they come together. So it's in A and B. So when you see this symbol, you can say A and B. It's in both A and B, which is the overlap, right? That's A intersect B. The elements that are common to both, they're located where the 2 sets overlap. Okay, so A and B. So this is read A and B, or A intersect B. Union of sets uses the word or. A union B, so that's easy, right? Because it's a U, so U for union. It's also on the formula sheet. Is the union of set A with set B. It denotes all elements that belong to set A or B or both. Okay, so it includes the overlap region. So it's everything that's A only, everything that's B only, and also everything that is A and B. Okay, just add up everything inside the circle, which is 3 regions. Okay, so A or B will be the sum of the numbers in the 3 regions. Subtraction of sets. A \B. Now the only place you're going to see that's in the textbook. Okay? But if you're doing a question in the textbook, you see a backslash. What it means is represents the elements in set A minus the elements in set B. It denotes the elements are in set A but not in set B. So the way that I would say that is only A or A only. Okay? So it's the ones that would be here, right? This is A only or only A. What do you prefer? Call it A only. Call it B only. Right? A and B. It is the shaded region in each of the following. So you can see that B is a subset of A. And that's what that means. It's also on your formula sheet. B is a subset of A. Means that B is going to be inside A, right? Like totally surrounded by A. And then A only is just the number that are here, right? The number that are only in A but not in B. If they are disjoint sets, life is easy, right? A is only A anyways. And when they intersect, then it's, again, it's A only, right? So not the intersection here. So you would subtract, if you had the numbers, you could subtract from the numbers. Consider the set A, -5, -3, -1, 1, 3, 5, and B, 1, 3, 5, 7, 9, 11. Complete a Venn diagram for these two sets. Let's call that A, let's call that B, let's fill that in. So I'm going to put, poof, as if by magic it's all filled in. So we just take each number, -5, and just say, where does this go, right? So you look at -5, you say, only A. This is the only A region. -3, only A. -1, only A. 1, A and B. 3, A and B. 5, A and B. 7, 9, 11, only B. So state A union B. What is the union? If I put these two sets together, what will I end up with? So in the union, we list everything that's either in A or B or both, but we don't repeat anything. Okay, so if something's in A and B, we don't list it twice. So just start off, we go, okay, -5, -3, -1, 1, 3, 5, 7, 9, 11. So the union is put together, it's in A or B or both. If you want to know how many there are, just go through the diagram and count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And again, you wouldn't double count anything. You say how many numbers are on the diagram. And then if we go up here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Which answers the next question, which is, what is the number in A union B? How many elements do we have? Well, we just said it twice. So there are 9 elements, right? No double counting. You don't put a number down twice. If it's an A and B, it just goes in the intersection. What is A intersect B? So what's in A and B? 1, 3, 5. So equals, it's a set, so we use the brace bracket. So it's the set consisting of 1, 3, 5. What are the number of elements in A union B? Sorry, A intersect B. How many? There are 3. So there are 3 elements in the intersection. Right? We're always talking about elements. An element is a member of a set. Each of these is an element. Mutually exclusive sets. 2 or more sets that do not overlap in a Venn diagram, meaning there are no common elements. The events in each set cannot occur at the same time. So you just think about it, if we were describing an event in words, then these events would not be able to occur at the same time. So like if I said we have a heart or a black card, we would say those can't both happen. You can have a heart or you can have a black card, but you can't have both. An example where you could, if I said a heart or a face card, then you'd say, well, you have hearts, but you also have face cards which are hearts. So both can happen. Mutually exclusive is they both can't happen. So either the sets are disjoint. So if you saw a diagram like this, AB, you would say they are mutually exclusive because there's no overlap. Or if you saw a diagram like this, and this was the number of elements. So each number here is how many elements. How many elements. And we would say there are 18 elements in the universal set. 18 elements in U, and 0 in A intersect B. So either they're disjoint, they're just two totally separate circles, right? Like we drew one, I think we had hearts and we had something else, diamonds or something. So hearts and diamonds would be two circles where there's no overlap. If you did draw them overlapping, so let's say I did hearts, diamonds, and we had how many, it would look like that. There are 13 hearts, only hearts. There are 13 only diamonds. There are no cards which are both hearts and diamonds. Okay, so disjoint sets, two totally separate circles, or the AND region, A and B, is empty. Right? It's either empty or there's a 0 in there. You could put a 0 in there. And in record time.